Caro, ¿comienzo?
Sí, ya. Pero ya, no.
Bueno, hola, ¿cómo están?
Caro, ¿comienzo?
Espera, yo
Sí,
cierro el
ya.
YouTube.
Pero ya, no.
Listo. Hola, ¿cómo están? Bienvenidos otra vez a un Meetup de Python. Esta vez tendremos a un speaker polaco, ya lo van a conocer. Este es un evento que hacemos cada mes, o lo intentamos hacer cada mes. Tenemos a los organizadores ahí. Quizás cada uno hablar en su respectivo espacio, apenas estemos haciendo las preguntas. Y un segundito. Estas son nuestras redes sociales para que nos sigan. En Python Medellín, en Instagram estamos constantemente colocando nuestros eventos, en Facebook también. En Python Medellín, en la página de Meetup también tenemos todos los eventos y también en Twitter, que lo cambiamos últimamente. Y antes de presentar al speaker, vamos a tener una presentación de Oscar, que hace parte de los sponsors. Entonces, no sé si, Caro, por favor, nos colocas a Oscar en la pantalla. Gracias. Listo, yo voy a dejar de compartir y le toca a Oscar.
Una disculpa, no había quitado el mute. Hola, ¿cómo están todos? Mi nombre es, como dijo William, Oscar Terrazas, Community Partnership Manager para Terminal en Latinoamérica. Y bueno, vengo solamente 3 minutitos, voy a ser muy rápido, a quitar un poco de su atención, a platicarles un poquito de Terminal, porque estamos muy emocionados de que a partir del mes de agosto estamos abriendo operaciones en Colombia. Es nuestro tercer país en el que estamos teniendo operaciones. Primero, bueno, ahorita les voy a platicar más, Canadá, México y ahora Colombia. Y ¿qué es Terminal? Bueno, Terminal es una compañía que busca habilitar al talento global para que pueda conectar con startups bien fondeadas, y esto es muy importante, que tengan también, que estén en una etapa de alto crecimiento. Es una compañía fundada en 2007 en Silicon Valley y fue fundada por Atomic. Atomic es una startup builder en Silicon Valley, en la cual lo que ellos se dedican es a encontrar áreas de oportunidad en el mercado para construir empresas que puedan atenderlas. Entonces, es una forma muy fácil de conectar y es de donde nace Terminal como tal. Actualmente ya somos 70 empleados o trabajadores de Terminal. Hemos levantado arriba de $30 millones en 3 rondas de inversión y a la fecha hemos contratado 260 ingenieros. Tenemos en el equipo 260 ingenieros trabajando para distintas startups, desde Silicon Valley, Nueva York, Austin, Texas, principalmente como los principales hubs tecnológicos de Estados Unidos. Y los mercados, como les había dicho, los mercados en los cuales operamos son Canadá, México, Colombia. Y algunos de nuestros inversionistas detrás de esos $30 millones, bueno, los más visibles son Thiel Corporation, bueno, Thiel Capital, perdón, de Peter Thiel, uno de los fundadores de LinkedIn y hoy de Palantir, que se está haciendo pública en estos días, y Kleiner Perkins, siendo uno de los principales inversionistas de los más viejos en Silicon Valley, que han confiado en el modelo que tenemos nosotros. ¿Y cuál es nuestro modelo? Bueno, en Silicon Valley existe una deformación en el mercado por las fuerzas de tanto de la oferta como de la demanda. Y encontramos que existe un cúmulo de startups que tienen product market fit, o sea, su producto ya se está vendiendo y encontraron al mercado al cual le quieren vender. Tienen capital, tienen por lo menos una serie A detrás, pero están viendo limitada su capacidad de crecimiento porque no han encontrado el talento o cuando lo encuentran, les dura muy poco, teniendo que eso es limitando la velocidad con la que ellos tienen que entregar resultados al mercado como el principal o a sus clientes como el principal foco, pero también a los inversionistas. Una solución para eso, y ha sido un poco difícil, y es donde entra Terminal, es buscar talento fuera de Silicon Valley. Pero el foco de cualquier startup, y los que sean aquí, que estén trabajando en su startup actualmente, saben que el foco es construir producto y vender más, o por lo menos llevarle la oferta de valor a nuestros clientes. Entonces, eso significa para cualquier startup el tener que dedicar tiempos y recursos a salir a explorar dónde está ese talento, ¿sí? Y hacer experimentos y sin caer en una burocracia o en un área más dentro de la empresa que les quite la velocidad a la cabeza, al liderazgo de la empresa para poder hacer esta tarea que les ayudará a encontrar ese talento. Y por el otro lado tenemos a los software developers. En este caso nosotros buscamos que sea nivel senior, ahorita lo voy a platicar más adelante, pero que están buscando, como buenos desarrolladores de software, siempre están buscando retos. No quieren ser parte solamente de un engrane en una gran maquinaria, sino quieren tener impacto en el producto, pero eso normalmente lleva a trabajar para startups que no les dan la estabilidad deseada. Y tampoco les dan el sueldo, el nivel de sueldo. Nosotros ofrecemos los niveles de sueldo más altos del mercado. Y aparte, la posibilidad de vivir la startup way o la forma en la que hace startup en los mercados más importantes de Estados Unidos. Y entonces nuestro trabajo es educar a los clientes en hacerles ver que no solo el talento está cerca de ellos geográficamente. Desgraciadamente, la situación actual nos ha ayudado a hacerles llegar ese mensaje mucho más poderoso para que nosotros podamos hacer el proceso de encontrar ese talento, contratarlo, brindarle soporte y acobijarlo como lo hace una startup de tecnología, conectar con sus pares, o sea, tener la posibilidad y las herramientas para conectar y trabajar desde casa y proveer al mismo tiempo oportunidades de aprendizaje y de crecimiento al talento en todo el mundo. Eso es básicamente lo que nosotros hacemos. Como les decía, abrimos operaciones en Colombia a partir de ya. Si ustedes entran a nuestro sitio, van a empezar a ver ya las vacantes, cómo van llegando poco a poco. Hoy tenemos 6 vacantes disponibles para Software Engineer Senior, que pueden encontrar en esta página y me gustaría que nos visitaran. Y bueno, hemos estado experimentando la forma de hacer los sponsorships para las comunidades. Yo vengo de las comunidades, yo estoy en Guadalajara, en México, y bueno, a mí me ha tocado desde 2012 trabajar con comunidades. Hoy estoy del otro lado trabajando con una empresa que me permite agregar valor a la comunidad. Y bueno, hoy no estamos físicamente y no tenemos un evento físicamente, y entonces lo que estamos haciendo es dando 2 suscripciones de 3 meses a Platzi para los community members. Al final de esta charla, que vamos a tener el día de hoy, vamos a hacer entrega de esas vamos a decir quiénes son los ganadores. Tienen que registrarse en esta URL que al ratito pongo ahí en el chat de YouTube para que tenerlos en la base de datos, hacer un random por ahí y sacar a los ganadores. Y ya por último, ya para poder pasar a lo que ustedes llegaron y ya no entretenerlos, aquí pueden encontrar las vacantes, también nosotros siempre estamos contratando, pueden encontrar las vacantes, pueden aplicar, nuestro proceso de aplicación es también muy sencillo y muy rápido. Una de las ventajas que nosotros ofrecemos a nuestros clientes es que puedan estar contratando en cuestión de semanas y no en tema de meses. Y bueno, yo me despido, les agradezco muchísimo. Voy a estar ahí en la charla de YouTube por si me quieren dejar mensaje. Y mi correo es oscar@terminal.io. Si tienen alguna duda, hablé muy rápido o estaba muy nervioso. Muchas gracias y mucho gusto.
Listo, muchas gracias, Oscar. Entonces, continuemos. Les voy a presentar a Powell. Powell lo conoció Jorge, que es nuestro chico internacional de coorganizadores. Jorge lo conoció en Dansk. No sé si se pronuncia así bien. Entonces, tenemos a Powell. Es un ingeniero electrónico. Hola, Powell. Powell va a dar la charla en inglés. Cualquier pregunta la pueden colocar ahí en español o inglés. Nosotros la traducimos al final de la charla. Y un poquito el background de Powell es que ha estado más que todo en empresas electrónicas. Está en este momento trabajando en Intel como software engineer. Y estas son las tecnologías que él está trabajando actualmente. Python 3.5, Airflow, que es como Dataflow, Flask, y ahí las pueden ver. También por si quieren chismosearle un poquito el LinkedIn, ahí lo tienen, y el GitHub, lo pueden encontrar como ese.borov. Y pues, no más. Powell, go ahead.
Okay, thanks. I hope you hear me well.
Yep.
First of all, hello to everyone. That's my first international meetup. So from this place, I would like to thank Jorge for making this happen. As I understood, I was already introduced what I'm doing. So yeah, basically I work currently at Intel in a graphic department division. where I'm working on stuff related to continuous integration and continuous delivery. And I'm Python developer daily, like for most of the time I'm working with this technology. And the reason why I'm here is because we met with Jorge a couple of years ago here when he was working in Gdańsk. And he actually delivered a couple of presentations back in the days when I was organizing similar meetup in Gdańsk. So we thought that it might be an interesting opportunity to that thanks to technology and thanks to remote meetups, maybe I could share some knowledge and experience with you guys. So it's a really great opportunity. So maybe before I will start the presentation, I will give you some, let's say, a philosophical background. What's the reason for this kind of presentation and why I decided to share some knowledge about what's generally called Python under the hood title. Every time a while I get question, either it's on an interview, some from just random people like, do you know Python? And to be honest, even though I've been working with Python for a couple of years now, I always get problem with answering this question because it's very broad. I mean, I know how to write code in Python. I know syntax. I think I know some principles. I think I'm writing Pythonish code. But when I started asking this question some time ago to myself, well, I ended up figuring out that there are dozens of things which I probably, well, I don't touch directly, but they affect things that I do. And this is all everything related to what's happening in Python when we actually use it. And this kind of topic is probably not the very basic kind of knowledge you're gonna gather whether you're when you're starting to learn Python, or maybe if you're working already a couple of months or years with this technology. But at some time, I think that it's really useful to get some background in the technology. I mean, you may be the developer, Python developer daily. You may be also someone who's using Python just for some kind of scripting, or maybe it's for some R&D work, and you're not really interested, or maybe you're not really aware what's happening under the language syntax and under the sugar that it's providing. However, I'm kind of fan of approach to know your tools, which means that it's really good to understand what's happening in the case of Python, for example, interpreter level, what's happening behind, because it all gives us insights about how the things works. And on the other hand, gathering this kind of knowledge, I think it makes us better software developers. So I thought that it might be interesting to share some of the things I have already learned. I'm not pretending to be any kind of master of Python interpreter level things and so on, but I would really like to share with you some of the things I have noticed, things I have figured out, things I have learned, and maybe it's going to inspire you to dig that topic a little bit farther. And to start with, I would like to say that I don't have presentation in a classical sense. I don't have any kind of slides. I will be doing some live coding. And the rule of thumb of live coding is that always something will go wrong. So please be patient if anything goes wrong. And nevertheless, please don't make any kind of notes or well, you can make screenshots, you can record it, sure, but if the topic interests you, I will just send at the end of the presentation, I will send you a link to everything described what I have done today in a format of Markdown. Plus, there will be some references, some links, some maybe information about there are some information about books which might be interesting for you to dig this topic farther. So yeah, let's start. Let's start with something very simple. We all probably know already that Python is object-oriented language, which is the very backbone and the most, let's say, natural element that people learn when they start figuring out Python. So we learned that we can define a class. Let's call it foo. Yes, very random name. So we have defined our class. Now the question is, what actually has happened? Like, okay, we have written some code, but in Python we know that everything is an object, which means that even a class definition is still an object. And Python provides us very simple built-in function, which basically we probably don't use it quite heavily directly, but it can give us information which is one of the most essential elements of Python, and it's called ID, which is built in Python function. So we can do ID foo, and we can see that it has returned something. Like we can write type foo, and we can learn that this is a class type, but actually that's still an object. Okay, that's cool, but it doesn't says a lot, because the reason why we write classes is just because we want to instantiate them, and that's obvious. So we can create an instance of our foo class, and it has been created. Now, what we haven't done, we haven't assigned it to a variable. And let's create a new class and assign it to variable. And this is something important is happening currently, which not many people mention. What we are actually doing, we are assigning right-hand side to the left-hand side, but the right-hand side is a object, while the left-hand side is called a name in Python. And instead of saying that we are actually assigning a variable to an object to variable, we are actually making binding between an object and associated name. So does it matter? I mean, yes, it does. Okay, we can refer to our foo object through this name, and even though we are referring in our code with the names, actually what's happening underneath the Python is using all those IDs. Now, apart from ID function, there is also one important, which is called hash. Not every object is hashable. That's related to object being immutable, but those which are mutable, which are, for example, list of dicts, that means the objects which may change in time are not hashable. Nevertheless, we've got this ID and this hash function, which is kind of funny because there is a relation between them. And at least at my PC, it's going to be hash bar. We can calculate relation between them, or rather bar divided by hash. It's 16. It's just kind of, I don't know if it matters, to be honest, but I have figured out that it's always 16. So if you're not overriding the default implementation of this dunder method hash, so there's clearly some relation between default implementation of hash and ID. Okay, but still, does ID function matter for us, for our daily development? We may not be interested in checking, for example, these numbers, because I don't remember ever having a case where actually I've used ID function like directly. But the thing is that actually we use this ID implicitly. That means every time we make some kind of comparison using is keyword in Python, we're actually using ID, because is operating on a ID. Okay, hash is on the other hand used by dictionaries. Now we can check some interesting properties of Python using the is keyword. So let's define two variables. Okay, what has happened here? We have assigned or binned two values to x and y, and there's nothing special about it. Yes, I mean, yeah, that's true. We got two objects assigned to variables. Sure. So if these are two objects, then obviously we can like check if they are somehow similar. So we can obviously compare it like this, but we may also check it like this, and it also returns true, which might be interesting at the beginning, because it doesn't seem to be the same object, isn't it? Well, okay, let's check it. Now, okay. Oh, sorry, I made a mistake. Yep, and oh, double. Okay. Well, it's still true. So this is interesting. Okay, just let's try something different. Let's try some big number like that. Okay, that's working. And I was expecting not to work it, to be honest. Is maybe there's a difference between versions of Python. Nevertheless, if we declare a bigger version, the bigger number, free two, that actually shouldn't be working. Oh, it is working. Okay. That's funny because it didn't work in the previous version of Python. Nevertheless, what I'm trying to show you is that Python is pre-caching some integer values, in fact. In previous version, it used to be, let's check it in previous version, and a Python 2. Okay. Equals 500 equals 500 x is y. It's still working. Interesting. Yeah. Nevertheless, I'm trying to see that Python is not actually creating any kind of new objects. In fact, it's reusing a lot of objects that are already being created, and some numbers are kind of pre-cached, so we are not like creating new objects. We are reusing the ones, and actually we are binding. We are just adding binding to the existing objects, just to another names, but we can refer to them using different names. So maybe to make it more clear, let's make class foo. And what we did was function. Now, imagine we would like to assign this bar to another variable. Let's call it a. And now, what we did, we just thinking quite frequently that we have assigned to a new variable, but we have actually done something a little bit different. And let me explain that with using some of sys functions. The function is called get Rif Count. So when you call it sys Rif Count, model sys has no sys Rif Count. What? Okay, it's get Rif Count. Yeah. Okay. Now, what is the Rif Count? Every time we assign an object to some specific name, we are adding a reference to this object. And Python tracks all these references to be able to garbage collect them in the future. And I will talk about this within a minute. Now, we're actually using the same object. It's constantly foo. You can check it, for example, calling like that. And we can compare it with A, and we may see that it is supposed to be the same object. So we are reusing resources, actually. Now, we can remove the binding by calling the built-in function, or rather keyword, called del. And there is an error name because there is no such name as A, because we deleted it, and it works as expected. Nevertheless, bar is there, still pointing to our object. Now, we can check the reference count, and what has happened is that it's now lower. I mean, yeah, it has been subtracted by 1. In fact, this function is not accurate, because the reference count for this particular name is 1, but it says this function always adds 1 because there's some reference, additional reference during evaluation of this function, as far as I understand it. So it's always ref count plus 1. So we have to, subtract that to get information about precise number of reference counts. Okay, that's cool. Let's do something different. Let's take this ID of bar and assign it to name called address. And we got our address. Cool. Now, what will happen if we perform the now, it doesn't exist. That's okay, but get this address. And what can we do about it? And this is something interesting, because even though we have removed the reference to an object, that doesn't mean that the object doesn't exist. It does, and it's living somewhere in the Python interpreter. It's not actually removed until garbage collector performs collecting. So even though we delete by using delete, we're not deleting the object, but we are deleting the reference, the binding between name and an object. And this is significant difference between removing an object itself. Now, there is a module called ctypes, which probably is not very popular. I mean, I don't know how frequently you use this module. I probably have never used it on production or any, let's say, important code just for figuring things out. Now, ctypes provides us a possibility to retrieve or access this object. So this is, we can write ctypes, then we can see long. Now it's called from address, and then we can provide our address, and then we can type value. Address is not defined, of course, because I have because of my mistake. Okay. It has returned something. All right, our garbage collector has already restored that. Yep. So I think it has been cleaned. So let's try again. What was it like? Bar equals the address. Address going to be ID of bar.
Oh, well,
yep.
Can you organize a little bit your mic? It's sounding no well in some cases.
Now?
Yeah, it's
okay.
Yeah, perfect. Yeah.
Okay, sorry. I mean, yeah, this.
I think that you can put that a little bit.
I look dumb, probably. Okay, so we got this address. Now,
thank you.
We can access through ctypes, yes, and it has returned. This actually has returned our direct information about reference count. So we now see that the bar is the bar is binded to some object, and it clearly says, I mean, it acts very similar to the function sysget ref count. However, this will return you the proper value of references. Now, as I stated, we can delete the binding. As you may see, it returns -1, which says that it actually means, I don't know why it's 0. It says clearly that it's not bound to any kind of variable or name. Yes. Now, having said that, maybe we could try to retrieve this object somehow. And there is a function for that. We can use it, and it's also in C types. It's called cast. And what it does, it actually casts our object to treat it as a Pi object. Bang, segmentation fault. Okay, that's unfortunately the possible ending of dealing with C types, because since we are dealing with addresses on in a Python interpreter, it actually can be collected automatically by garbage collector. What I mean by that is, since we deleted the bar, probably garbage collector has figured that out and has removed this object already. Let's get back. Let's call it again foo bar equals foo. Now import C types. The address will be ID bar. And yep, again, that should return our object, and it works. Sure, great. I mean, that is what I'm expected. I'm happy that it works. So we can delete the binding now. Yet we can still access the object, and we can assign it to our bar, and bam, we get again access to our object, to which we have previously removed the binding, which means that what happened previously here, the core dump which has happened, the reason for that is we've got garbage collector which is working in the background. We have very limited control over it. I mean, there is a GC module which allows to perform some, let's say, garbage collecting. I mean, you can force garbage collecting, but that doesn't mean the garbage collecting will be evoked still, since garbage collector only knows when it's going to work and when it's going to collect the garbage. So probably you don't have a reason to use that. Nevertheless, even though we remove the binding to an object, it still exists somewhere in a memory until it is cleaned by garbage collector. So as I have shown you, we can even retrieve the object from the depths of the memory and assign it again to our name, which is interesting, at least. Now, does it matter? We probably use daily this kind of, I mean, creating new objects and binding them to new names happen all the time. For example, when you use list comprehension. So if you define a list, and you can check an ID, fine. Then you wish to perform some list comprehension. So let's write X for X and A, if A smaller than 2, for example. Yes. What I did wrong here. Okay, not A, but of course X. Now, what has happened is that those IDs differ. Now, it clearly means that list comprehension, what it does, it actually creates a new object underneath. So the new object is created. The old one exists somewhere in the memory. We can try to, if it was the garbage collected yet we can try to retrieve it. Yes, and we did that. So it still exists in the memory. Now we can do GC. We can make GC. GC. What was the collect? Yeah, collect. It probably did some collection, and no, not yet. It's still there. As I mentioned, even though we say garbage collector to collect garbages, doesn't mean that it's going to collect it. Nevertheless, it should somewhere over the time remove this object. We can even try to check whether it's used or not. C type has address by object was a dysfunction. It's not dysfunction. Just a second. Bang, bang, bang. That was this from address. Sure. That was this from address. And we may want to use this address without this. Okay, so it's somewhere binned. That's why I didn't remove it. It's somewhere, it's binned somewhere underneath and still use, or maybe I'm not referring to the proper name. So this, yeah, okay, yeah, the problem was, that was probably the wrong address. Yeah, okay. Still, it's somewhere, it's bind somewhere. Maybe I will clear our A equals 1, 2, 3. ID of A. Yep. A equals x for x in A if x smaller than 2. A, okay, the first ID A, okay, import C types. Now this is going to be this. Let's use the address of a first element. All right. Okay. Yeah. Sure. Import C types. Oh, didn't work. Okay. Okay. So it's still somewhere referred, probably used by maybe it's being used somewhere on the interpreter level. Nevertheless, we may see that these are different objects. So every time we perform list comprehension, dict comprehension, any kind of right-hand side elements operations, Python will return just a new objects. So it's just worth to know that. Also, C types provides us. Yeah, there's there is this function gc get import gc import gc.
Hey, Paolo.
Yeah.
Sorry for interrupting you again. Sure. Can we try something in the settings for cam and mic? Can we like try to put a lower resolution for the video? Because we are like hearing you sometimes like cutting your voice. Yeah. So we would like to try in show advance in camera resolution to lower definition. Could be.
Okay. I mean, it's me who should do that.
Yep.
Okay. Manage maybe somewhere over here. You know, guys, and how about doing that?
I don't know.
You don't see me, guys, but
yeah.
Okay. Just a second. I don't know how to do that actually.
Okay. The guys agree that we can turn off the camera. Yep.
Okay.
That would be better. Yep.
Okay. Sorry for problems.
You can click on stop cam and that's it, I think. Yeah.
It shouldn't be
okay.
showing anything. Like if you still if the like connection is wrong, then just interrupt me, please. Yes.
Okay.
So yep. From the GC, we can actually get also information. What is this object? What are the reference of a particular name in case it points to the list of one. But if we define our foo class and let's say bar equals foo, and we can use this reference bar, so it shows directly to what we are bind by using like it refers to particular actually object to which it's bound. So that's cool. Let's check what happens if we write foo. Yep, and it will return us the class. It's actually the class. So from the GC module and the name, we can actually get the direct object to which it's pointing, which is cool. Now I won't be covering the GC module to match and the garbage collector because it's a topic for another presentation probably. And the materials I always send you, there will be some bullet points with keywords which might be interesting for you. So you can Google them, and these are just basic information about garbage collector keywords, and there are some reference to materials which might be interesting for you guys. Now, one thing that is worth mentioning is that in our C types call, we did a casting to ctypes.py object. Now, this is something interesting because everything in Python is an object. And in fact, everything can be treated as an Py object. If we look into Python implementation and interpreter level, we will find a structure called Py object. Now, we can actually take a look at that. It's located in CPython include object H. We may find it here. And where is it? Py object structure. There's some head. If you have never looked into Python source code, I think it's very elegant. Nevertheless, it's also used very, very heavily all kinds of macros, which sometimes make it hard to maybe to read if you're not experienced in macros. Yeah, so this is a very basic structure in Python code, especially in CPython. Now, everything can be underneath, like the Py object, as the source code says. It's never used directly. I mean, there is no instance of Py object in an interpreter itself. However, it acts kind of like an interface. So every object that it's declared in Python C code can actually be accessed through this interface of Py object. That's why we actually make this kind of casting here to treat the address as a Python object. And then from information like Py object type, and probably some Py size, and some extra information in the header, Python is able to retrieve the information about a particular object. So this is interesting. If you want to explore a little bit more what are the structures in CPython, there is a reference in CAPI documentation, and there is description of all kinds of structures that are used and are declared in CPython. So if you find it interesting, you can start digging here. And there's a brief description what particular objects are doing, or like how they are defined. Now, okay, let's go further. And let's go to something maybe more interesting, which is a list. List in Python. Very popular structure. So we may be interested in checking what's the actual size of list. So we can use this function, which is called getSizeOf. You can use getSizeOf my list. Now let has returned some number. The number is a memory occupied by this structure in a memory, and it's 64 bytes because it returns the size in bytes. Okay, cool. Now let's add an element to our list. That's some number. Now as we may expect, the size should change, and that's very cool. Now, okay, let's add another number. So the list should grow, but the fact is that it doesn't. Now, okay, maybe this is just an error. Let's check it, but see, yet still it doesn't grow. But the question is why? We are adding elements and it's not growing. So, and now it did. So what actually happens here is that each time we declare a list and add an element, there is some additional pre-allocation happening. So even though you add only one element, Python is already prepared that there's going to be more elements added to the list, and it pre-allocates some amount of memory. And actually, this is not a random amount of memory. It's declared in source code. So you can perform fast appends, fast insertions without having need to reallocating memory, because reallocating memory is a cost. And that's why this is one of the costs of I have mentioned in the presentation description that every abstraction comes with some costs, and Python has this ability to like pre-allocate some resources to make effective usage of them. So if you remove an element from the list, it also doesn't resize until some point. So if you remove elements from list, it will reallocate, it will resize the list as well. So both in a situation of growing and shortening the list, the occupied size will differ. Now, one may be interested, what's the how it works, and this presentation I will be sending to you later. I mean, here is a list allocation equation. So it basically says that between like 1 and 4 elements, there are 4 elements. There is place for 4 elements. If you increase the number of elements, then it will allocate more and more memory to keep these elements. And in fact, this allocation, it's all about having a reference to other objects. So each memory slot, each memory chunk, it's just the size of a pi object pointer. So it occupies 8 bytes of memory, at least on my system. I don't know which. Yeah, it's system related probably. And as you can see in source code, they state that it's working fine for built-in, but I mean this information about occupied memory, but that doesn't mean it's going to work properly for third parties. Yep. So as I said, when you create a function, a list, there is some pre-allocation. Now, this means that it grows, and the more elements you're adding, the more you are over-allocating. In fact, it's not that huge over-allocation in case of lists, but it differs a little bit in case of dictionary. So I will show you just how dictionary works underneath. So imagine we've got dict, and let's check the size. Okay, there is some size, definitely bigger than the default list size. Now, if you add insert like some element here, you may find that similar to list, it's the size didn't change. Now we can put more elements. And still is the same size. Okay. Oh, now it has grown. So we have increased the amount occupied by the certain dictionary. Now, what has happened underneath is that by default, if you create a dictionary, empty dictionary, it will assign memory space for 8 elements. And the logic behind this is that if it's full in a 66%, like 2/3, it will resize the dictionary, and it will increase the number of occupied space. And this basically it's like it grows from 4 times, from 8 to 32, 128, and so on until it reaches 50K. And if we exceed 50K of elements in our dictionary, it will resize twice every time we insert anything new. Now, this is kind of, very simple optimization, but it's good to know that there is this over allocation, and if we need any kind of let's say, maybe it's better to use smaller dicts, or maybe it's better to, rather than dynamically create dicts, maybe it's better to create once your dict and do not perform any kind of insertion to it if you have this kind of possibility. Now, good thing is to know how actually dict works underneath, and it's very simple. It uses hash, as I have mentioned. So imagine that we've got some hash of an object, and we would like to calculate the index in which the object will be stored, under which index object will be stored in the dictionary. And imagine we've got an empty dict, like my dict equals it's empty dict. Now, as I have stated at the beginning, it pre-allocates space for 8 elements at the beginning. So it calculates the mask as 8 minus 1, always minus 1. So it's the size, it's the amount of allocated chunks of memory. And then what it does, it just performs a AND operation, and it returns 1. And 1 is going to be an index in your dictionary under which the particular object will be stored. Now, it's not storing only the object, but also the key, because there is such thing as collisions of a hash function, or collisions of a hash function. Hash function can collide, which means that, for example, well, if not hash, but hash and mask calculated, there is high probability that there is going to be some collision. That means that the same objects may be stored at the same index, which actually means that if that happens, the new index will be calculated, and the index value is like the calculated index plus 1. So if we would have another object which we would like to store in this dictionary, and cache and mask operation would return 1 as well. So it would just so the new index for the second object would be just 2. If again that wasn't empty, then that would be increased to 3. So that's how it works. And what's important to know is that the index calculation is not to really focus on avoiding collisions. That's not the goal. This function is very, very simple yet efficient, because since we have to resize dictionaries quite frequently, we may be resizing quite frequently, we would have to recalculate both masks and the dictionary hashes on and on. So it's all about being fast and performed well, rather than avoiding collisions. So nothing, hardcore here. So yeah, it's an interesting like implementation detail. Now, when it comes to tuples, it's actually nothing interesting. Like in general, tuples are not interesting because they've got fixed size, and it's just going to return the size. Nothing fancy about
tuples. Yeah, so
that's the basics about how standard containers works in Python. Maybe we could actually try set. Set is declared something like that. Yep. So size of set. Oh yeah, set equal that was dump. I have overridden the built-in. My set equals 1, 2, 3. Import sys, yeah. Sys get size of my set. Module sys has no attribute get size. It doesn't. Okay, so set is quite big, I would say. Yeah, because a set is just a dictionary underneath, actually. That's how it should work. So yeah, nothing fancy here. That you can check whether it how was like my set. Okay, what was the set? Insert Python. Let's check it. I have a new set. Set add. I haven't used set for a long time, to be honest. Okay, so we can add my set add. And will it work? Yeah, it worked. Okay, so we may see that set also probably pre-alloc some space for eventual adding new elements. That seems logical because it works very similar to dictionary. Now, other interesting things in Python are frames. Frame is representation of the code at runtime. Now, looking at the frames can be actually sometimes useful. And it's worth to know that Python interpreter is implemented as something which is called a stack machine, which is like kind of it operates over virtual stack, where it acts like the traditional stack machine with frames, whereas frames are actually objects in Python, which means that we can access them. We can access the frame object, and we can learn some interesting stuff about inspect about frames. So let's define some hello function, and what might be interesting for us is a current frame And we can then
use inspect get
current frame. Yep. Okay. Launch it.
nothing returned because it hasn't had a
Print. Yep. Okay. Hello. Yeah. So there's a frame object.
and it's a regular
Python frame object. We can even access it using this address with our previously presented function from C-types. So, and for example, where it was. Yeah, not this one, not this one. From address, was it from address? I have good memory, but short, unfortunately. Okay, this returns the Rif Count, which is 0, which makes sense currently because the function has evaluated and the frame is not used anymore. Now I was interested in function called cast. Yeah, that was the function. I hope garbage collector has not cleaned it yet. Otherwise, we will end up in core dump. Yeah, but there's a frame object, so we can just assign it my frame, and we can now access it. My frame, and as you may see, it's a regular object. We may access
locals, some information, some
let's say, okay, let's take my frame if locals, it's empty. Okay, but we may look at the code.
there's code objects, which again
we may
explore what's happening there. And yeah, we may, for example, check what are some defined names in that frame, and it's enter names. And yeah, these are the names.
Current frame print. Because we have defined the current frame. Yeah, here it is. The print. It's a function, but also it's also a name to a function, as I understand that. So it's also defined there. This is the current frame to which we have assigned, and inspect. Yes, so we can access kind of different things. Let's have a look at stack size too. Whatever that says, maybe it's in bytes or whatever. I don't know, to be honest. What's the name? Hello. Yes. So as you may see from the frame object and from the code object that it points to, we can retrieve the whole information about code objects and maybe do some modification at runtime. Now, is it useful? And the answer is actually it can be useful because you might be working on some debug or maybe some kind of logger, or maybe you're working on some, I don't know, maybe some kind of tool, and you need information where particular function was invoked, where it was called, maybe with what kind of arguments. Maybe you want to get some specific information because you're doing some kind of debug. And in this case, the frames actually might be useful. And to be honest, I once had this situation, and I even had this kind of solution working on production where I had to take some value of a variable from the previous frame or even the frame before, because some built-in was overridden by some third-party library, and I needed to use the proper built-in behavior rather than the one that was overridden. So it really helped me a lot, and it worked, and it acted like a decorator to some function, and it was pure fun to make this kind of hacks. You know, if you do regular development, you probably don't have too many opportunities to figure this kind of thing. So it's always fun for me when I can like use kind of dirty hacks to achieve something what I wanted. Yeah, fun fact. The last thing I actually wanted to talk is give you very brief description of this module. And this is one of these modules you probably never going to use, but it's still fun to know how to use it and what it can actually do, because it can point you to moments when you will learn a lot about how Python works internally. Now, the this stands for disassembly or disassembler. Nevertheless, we have to know that, in fact, we are not operating on an actual Python code. When we execute code, we are working on a bytecode. Now, bytecode is our Python code translated to some lower level code, maybe with some optimizations. Nevertheless, interpreter works on this bytecode rather than real code, because every function, every assignment, every evaluation of every function, every call is translated into some set of instructions, which are then understood by Python interpreter. Now, you may sometimes find files which are called PYC, which stands for Python code, this binary code. Now, this bytecode. Now, we can actually use this assembler, this module, to get insights about how our function, how our class would be declared in bytecode. So, do we have our foo? No, we don't have. Okay. So, foo. Was it there? No. So, class foo. Yes. Or equals foo. Now, is why did it work actually? Okay, just a second. Oh, maybe I was expected to do full. Not. Okay, weird. Just a second. Yeah, okay, well, let's use the hello word. The hello. Okay, it works for functions. Maybe it makes sense. Okay, what we may see here is the bytecode representation of our function. What's actually happening there? Now, there are some kind of bunch of names, just load global, load attribute, call function. It's kind of, Python's assembler. So, and actually you can check the definitions of each instruction, and of course, Python source code. And these are called opcodes, actually. So there are some numbers. It operates over on the numbers, and there is a definition what particular number is responsible for what. Now, what it actually gives us, it doesn't make too much sense unless we look at the other file, And this other file is called C eval C file in source code. Now this is the very main, let's say it, it's a main Python's interpreter loop function. So we may see that there is a big switch where we provide opcode, and based on a kind of operation we are doing, it's going to perform some dedicated operation, and it's actually the core Python function. Yes, this is this part of interpreter that works in the background, performs one big while function, and it constantly
operate over the instructions, which are
in this kind of format. Yes, like in this kind of format. So it iterates, it follows that there's a call function. Let's check what's going to happen when we see the call function. Predict target call function, and then is something happening. Yes, it gets the stack pointer, it calls the function which is expected to be called, performs some operations, then it goes further. So if someone asks you how Python works underneath, the answer is that it transforms your code into bytecode, then it iterates constantly over the opcodes, which are just a fancy names for some numbers which identify what should be done when some certain opcode arrives. And that's basically it. That's how Python works underneath. So with this presentation, obviously I was only touching the very tip of a big mountain of different topics. Nevertheless, I think that the topic is really interesting. It's huge, but what I would really like, what would stay with you at the end of the day, whether you're a professional Python developer, like daily Python developer, or maybe you're just starting, or maybe you're using Python just for some scripting. First thing to remember is that a lot of interesting things are happening underneath, but that doesn't maybe mean a lot. Nevertheless, I highly encourage you guys to spend some time figuring out how actually Python work underneath, because while you understand that and while you get comfortable with that, then maybe some of the elements of the languages will be easier to understand in the future. And for example, seeing this kind of big loop, it makes me kind of let's say, it makes me understand better the problem of parallel computing and Python, because there's only one thread constantly iterating over the same loop, checking for just the opcodes. And when you see that, it's easy for you to understand why is that happening. There are obviously some related variables to this operation, so making it parallel would require, I don't know, maybe some kind of weird branch predicting, and then I don't know. I imagine that this is one of the reasons why it's really probably hard to implement some parallel computing, like if everything iterates over one loop. So the multi-threading is a big threat in Python, and like you may be using some third-party libraries to overcome this. Yep, and in terms of resources and maybe where to start, since I'm getting closer to the end of my presentation, I will guys send you that link. You can have a look, actually. Now, I have included the resources list of some of resources that might be interesting for you. Now, some of them are hardcore, some of them are not. Like, you may find the 10-hour CPython interpreter tutorial. This is, frankly speaking, a really, really, really good material, but it takes 10 hours to, to view everything. And it touches only, the tip of a huge amount of problems. Nevertheless, it's very interesting. There is also a fresh book which is called CPython Internals, which I've got it, I bought it, but I didn't have enough time to sit down and figure out everything from that. What is nice is that it's 3.9 interpreter version, which is really cool. So if you wish to learn something new about interpreter level things, this book, based upon what I have already seen, and that it's really good. It's a really good book. Now, obviously, the Python source code is a good place to, well, let's say, yeah, maybe it's not a really good place to start with because there are a lot of things happening, but it's always a good reference place. There's a cool thing about frames visualization, how they work. In general, there's the site Python Tutor. So it shows, it represents everything in graphics format. This is very cool. This is you can learn a lot from that. There is some GC explained, and also across this file you may find also references to source code and source code. And please take everything what you need and, like, I don't know, share it, use it. And like, again, I'm thinking, well, this didn't work as expected because previously it did. The small integers caching, but I would have to sit down and figure out. Nevertheless, the idea behind that was that between numbers -5 and 256, Python was pre-caching the values. And even though you assign specific integer like 1 or 2, it always reuses the same objects. Now, maybe it has something changed with the newest version of Python and the range has been extended. Now there's one thing which I wanted to just mention, getting back to IDs, and is none. None is an object. If you type none, you can see clearly that
It's a class, and you can return an ID to none. And we can actually get Rif Count. Rif Count. Of course, yes. You can see that there are a lot of references to non-objects. So
now you may see while we are checking if A is none, because S operates on an ID, while none is an
object. It just checks. There is one none over the whole interpreter, the whole Python while you work, and it just checks whether the none is assigned to
A, and since
it's working on an address, we are not using this kind of comparison, which is if you were wondering why we use if and none, that's the reason, because this ID and it's a
what should I call it? It's the only one object. It's a singleton. Yeah, that was the word I was searching for. None is a singleton. So that's how it works. And yeah, basically that's it. That's I think everything I wanted to cover today. Sorry for. I hope like the presentation, like the sound quality was okay. Sorry for some issues and ambiguities during the presentation, but as I said, when you do live demo, something always goes wrong. So I hope you guys enjoyed it. I hope it brought some interesting knowledge to you, and yeah, I hope you're gonna explore this topic because it's really cool. Thanks, guys.
Hey, man, thank you very much for this talk. I believe even though with the issues we got in terms of the sound, we were not hearing you well in some parts. It was great, man. If we want to like catch up or like wrap it up, was like, you know, we learned about memories management with this Rif Count, pre-allocations in terms of some data structures, lists, dictionaries, also how or why none is a singleton. So I think we learned a lot, and this is what we wanted to achieve. So we got a few questions, Pavel, and actually,
Sure.
yeah, that's the first question on screen. What is your GitHub?
Oh yeah, sure. I can show you my GitHub as sure. I have provided the link in a. Here's my general. That's the main site of my GitHub. But with this link again, this is the direct link to the MD file, Markdown file, where you may find basically everything I have covered with some notes. Yeah, that's what I have shown. So you can use it as a reference to go further.
I have a question myself. So before we move on to the next one, let me ask you this, man. I also got surprised a few months ago because I was also trying the integer caching. And if you want perhaps to share your screen again, I'm going to show you how we can get the same result. And maybe on your, yeah, the thing is that if you use the tuple assignation, so, you know, the interpreter got like smarter, but if you define the numbers in different lines, you're gonna get that false you were looking for.
Okay, maybe.
Yeah, and you know what is weird? Like if you run this code,
let's check it.
Let's do it. Yes. I was also saying some what the fuck is going on a few months ago. So let's try that. Define the variables in different lines.
Okay, you mean that? Okay, you mean like x equals 1. Yep.
Yeah.
X is y. Yeah, it's true. Okay. Yeah. X equal, let's say. False. Yeah, that's what I was searching for.
Yeah. There we go. And the reason.
Yeah, you've got me, man.
No, because I suffered the same few months ago, and I was wondering why. So the reason for that is that actually, man, if you run that on the script, you might get through.
Okay.
Because the interpreter got smarter, and it has different behaviors for different OS. So now the bytecodes are more optimized.
Okay.
So they are able to cache bigger numbers. That's what is happening.
Possibly that's true. Let's say the original specification, as far as I know, was that it was intended to cache values from -5 to 100 to 255 or 54, 56, whatever, like this kind of numbers. And the reason was that these were arbitrary chosen numbers because probably designers could figure out that these are one of the most popular numbers used. Whether you iterate, access, any kind of list indexes or whatever, you barely ever I don't know, if I manually try to access something, I always probably use the basic 0 to 10 numbers. I mean, these are the most popular. So they are pre-cached and they are stored as a 1 value. And you can even you can check the ID of a such number, and you can see use the sys get ref count from this. Oh, let's say a equals 1. Sys get ref count a, and you may see that it's used widely, like everywhere in the Python. So it's not that we only use it; it's used somewhere in the background in the code. And this is fascinating, I think. I know that a lot of people won't matter. Nevertheless, these are the kind of things that at the beginning they may blow your mind. But to be honest, in some situation, if you are not aware about some kind of, I mean, maybe not, this is not the case, but there are sometimes situations when you are not aware about some, let's say, implementation specific elements, it can end up very, very wrong for you. And you may end up debugging something that is just a feature of a, for example, interpreter. Now, yet again, it's cool to know this kind of thing. As I said, of using those frames, it literally has saved my ass once time. That it was very useful. So these are kind of dirty hacks, which I really enjoy doing. But it's kind of like stuff with metadata. I mean, meta classes. Like everyone heard about meta classes, but no one basically use them unless you've got a really, really good excuse to use it. And I've fooled with meta classes here and there in my free time, but never had actually an opportunity to use it on a production. Nevertheless, it's still fun to explore this kind of thing.
Yeah, thank you, man. So, Willie, next question.
So, Powell, we have a question from Diego, which is, in which kind of scenarios would you care about using the GC model?
Okay, that's a good question. Actually, the simpler question is you shouldn't. That's because even though you, like, as I stated during the presentation, and I don't think it has changed, but it's been a feature of Garbage Collector for many, let's say, years, as far as I know, is that even though you perform the collection, the gc.collection collect function you evoke it still doesn't mean that Garbage Collector is going to collect this garbage. I mean, it may happen. You can try to do that, but you can set some garbage collector properties like thresholds and so on and so on. Nevertheless, I didn't try to use this kind of stuff on a production. I would say that maybe in a situation when you are very dependent on a memory, for example, you could try to use it. Now, there is one topic which I'm currently exploring in the free time, and I've got this kind of gut feeling that it might be useful in the future, and it's called a serverless and lambdas. Because maybe, I'm not sure. That's my, let's say, that's my theory, that in the case of, I've been recently fooling around with AWS Lambda and all this kind of stuff that is launching your, single function in a container. I think that in this case, resources are very valuable. I mean, we are not. We get used somehow to situation when we've got dozens amount of memories, like our PCs are strong, our servers are strong. Even though, like, even a Raspberry Pi can be very effective, but in terms of Lambda, I'm thinking that maybe being more aware about memory might be the case when we might be, required to use maybe GC or some more sophisticated optimization regarding memory a bit more, because we want to spawn multiple functions, multiple lambdas that will operate fast. And the memory might be an issue there again. So in general, if you're writing kind of, if you're doing scripting job that it's automating your tasks, you don't need it. If you're working on a microservice that's a big microservice that, I mean, maybe, but still I didn't have a case where I had to use it. Maybe we could have tried it in a situation when our API was getting huge amount of requests and it was just stacking. Maybe using kind of GC could help, but in fact we were restarting API, which was simpler. So to answer your question, don't use it, but you can explore it. At least this is advice from me. Sorry if that's disappointing. Jython and PyPy. That's a good question. All these function. Which kind of function are you specifically are you talking about? Because
I think Carlos is like meaning the ref counting, the get size for the dates and list, the frames things. Are they available in other Python implementations?
I think so, because they're part of standard library modules. I don't know what they're gonna return, because that's a difference. However, that's a built-in Python module, and the idea is that you should be able to run your code in a PyPy or Jython. I have never used Jython. I think I have tried PyPy a couple of years ago, and if it's part of a standard Python library, so like sys is, well, sys there are some operational system dependencies. So depending whether you're working on Mac or Linux or Windows, some implementation details may change. Yet again, I think that sys get ref count would should work, unless there is some change in the garbage collector in PyPy. I know that it has some JIT solution. Garbage. I will just check it. PyPy garbage.
Documentation configuration. That's a good question.
I have never tried it, collect step, but I would expect that at least it wouldn't fall.
Right, and I think that yeah, it's a very nice question in the sense, like, you know, since they don't use the same memory management, at least I know that Jython doesn't use the counting reference for objects. It's kind of, yeah, it makes me like think of, okay, so if I run that there first, is it available? Second, what is going to return if the memory management is different? So yes, Carlos.
Yeah, it would be
very nice question.
Check it. That's a good question. I will figure it out. Yeah, you got me thinking.
Cool. Next question.
We have the final one, which is what is a fast way of pre-allocating memory if I am expecting to use a large dictionary or list?
Okay. Pre-allocating size. If that was a list, that would be simple answer, because if there's a list, if you like, I know the question is about dictionary, and I don't have a good answer for that, so I will talk about lists at the beginning.
I figure out the if you define
a list like that,
that means exclusively. Then
it's not going to pre-allocate. It's not going to pre-allocate, and it will define the accurate size of a list. Now, in terms of dictionaries, we can actually check that. My guess is that if you explicitly declare dict like key 1 equals 1 and so on, let's check it for one element. So my guess is that it will only allocate amount of memory only for this one element. That's my gut feeling, but I'm not sure. This is get size of my dict. Oh, it didn't, so it still pre-allocates. Now, so this means that probably you can't set the fixed size of a Python dictionary. At least I'm not aware of that. Python fixed size. Maybe Google will say something. Not really. I don't know. To be honest, I don't know. But my observation is that don't use too big dictionaries. Actually, it's better to have a dictionary which includes the dictionary, which will probably occupy a smaller amount of memory rather than having a one big dictionary, because you will create, like, I don't know, tens of smaller dictionaries, which memory sum will be still smaller than having one big, which could accommodate, like, hundreds of objects. Now, this is my observation. Yep.
Cool, man. So I think we are done with the questions. Fabio, thank you very much again, man. Thank you for your time. And
okay,
I cannot appreciate.
I'm glad you've enjoyed it, guys, or at least you say so. Now, I would like to thank you all for having this opportunity to speak to you, to present some interesting topic. And yeah, I'm really happy. I'm really happy that we managed to figure this out, and that we live in a days that we can make an online meetup and share knowledge across the ocean. This is really cool. I hope you guys keep well there in the current situation. And yeah, have a good day.
You too, my friend.
You too.
It was very nice to see you.
You too, guys.
Bye-bye.
Bye-bye.
Thanks. Bye.
So, ahora sigue Oscar con la rifa. Estás muteado.
Listo. ¿Me escuchan bien ahora sí?
Sí.
Bueno, ya cerré el formulario. Voy a compartir mi pantalla para fines de transparencia. Se registraron 21 personas. Si me ayudan ahorita. No, perdón. ¿Dónde lo puse? Aquí está. Ahora sí, ¿ven mi pantalla? ¿Ven una spreadsheet de Google?
Sí, sí.
Perfecto. Bueno, la dinámica va a ser, aquí ya hay, como pueden ver en la pantalla, hay una fórmula de run between. Aquí están todos los registrados, ¿sí? Y más a la izquierda están los nombres de cada quien y los correos. Lo que voy a hacer es, aquí hay dos fórmulas de run between. Como tenemos dos ganadores, vamos a hacerlo dos veces. Pero para darle más randomness a este asunto, vamos a hacer, la fórmula se actualiza cada que yo hago un cambio en la hoja de cálculo. Entonces vamos a contar hasta 3, voy a contar hasta 3 para que el número que nos arroje, los dos números que nos arroje, son los ganadores de las becas. ¿Qué vamos a hacer después? Yo vamos a nada más a decir sus nombres aquí y después yo les voy a mandar un correíto para pedirles la información que me pide a mi Platzi para dar de alta sus cuentas por 3 meses, ¿va? Entonces, si nadie tiene algún comentario al respecto, voy a continuar. Entonces, el primero va a ser el contar primero el 1, 2, 3. Entonces voy a copiarlos y pegarlos como valor, porque no vaya a ser que se me pierdan. El 3 y el 15. Entonces, el 3 es Andrés Jerónimo Escobar. Vamos a poner su nombre. Y el 15 es David Sánchez Valle. Y bueno, esos son los ganadores. Muchas felicidades. Yo los voy a contactar por correo y, bueno, para poder pasarles los datos para que puedan acceder a su cuenta de Platzi por 3 meses. Muchísimas gracias a ustedes por el tiempo y por la atención. Y bueno, vamos a seguir teniendo este tipo de dinámicas, esperemos, y espero verlos el próximo mes también, si me invitan. ¿Va?
Claro
Muchas
que sí, Oscar.
gracias.
Muchas gracias. Muchachos, eso es todo. Gracias por asistir. Nos vemos el otro mes. Vamos a ver qué charlas buenas les podemos traer. Y ya. ¿Algo más, Jorge?
Sí, de pronto también podemos hacer la dinámica a la inversa, ¿no? Si alguien en el chat, en la comunidad quiere animarse a dar una charla en el Meetup de Polonia, en inglés, go for it, my friends. Esa es la idea, unir las comunidades y aprender de pronto entre nosotros. Oscar, si vos tenés comunidades de Python en México con las que nos podamos contactar y hacer la misma dinámica, sería también súper.
Sí, platiquemos sobre eso y ver cómo podemos a unirlas a los dos países, ¿no?
Sí.
Perfecto.
Listo.
Muchas
Eso es
gracias.
todo. Hasta luego.